Okay, so for question 20, we're being asked to calculate the enthalpy of formation of this substance, butyl 1,3-diene. So because we've got an enthalpy of formation, we know that whatever we are starting with must be starting from its constituent elements in their standard states, etc., etc. And they are forming the product, which in this case, the question is saying it is C4H6. Okay, so we know that whatever this question is going from the elements to the product, standard states, etc. Now, the table of data gives us combustions. It gives us the combustion of C4H6 substance, and it gives us the combustions of both carbon and hydrogen, which are presumably going to be the elements to make up C4H6, which makes sense. So because they're using combustions, the products of combustion are always going to be carbon dioxide and water. And so because we have the combustion data for each of the three substances that we need, that is now our common point, and we can now create a Hess cycle. So from our product, that is going to go that way because it's combustion, it's producing CO2. And our elements are going to go towards carbon dioxide. That's going to be for the carbon element, and obviously towards water. That's going to be for the hydrogen element. So now what we have is the cycle built up. So what we now know is that the question mark, so the point of the question, is going to be equal to arrow number 1 plus arrow number 2, but this time it's going to be minus this arrow because this arrow here is going the wrong way. So what we're going to have to do is change the sign of this arrow and send it the other way, because what we need to do, remember, is we need to go from elements to products, but we need to go via an independent route. So we're going to go from here via there to that product. So what we're going to have to do is reverse that final arrow. So for the final number, arrow 3, what it's going to be is a subtraction. We're going to minus whatever that value comes in as. And then what we need to do is ultimately just number crunch this data. So in order to calculate the carbons, there's 4 carbons in that molecule, so we're going to end up with 4 carbon dioxides. So arrow number 1 is going to be equal to 4 times minus 394. We're going to add that to arrow number 2. That is going to be, we've got 6 hydrogens over there, so we're going to end up with 3 lots of water molecules in there. So we're going to add that to 3 lots of minus 286, taking those numbers from the table. And then, remember, this is the final part. We're going to, in this part, subtract arrow number 3. And arrow number 3 is a minus number, so we're going to end with a minus of a minus at some point, but that's minus 2,546. Okay, so once you've got all that data, number crunch it away, and ultimately comes out as plus 112 kilojoules per mole.